Hello everybody, welcome to one more episode about our serialization series. The main idea of this episode is just to create a serializer that takes an object, any object, and serialize to JSON. There are a lot of challenges that should be overcome, and we are taking them as they come in each one of these episodes. In this fifth episode, I'm approaching the serialization of lists, maps, and collections, and by the way, arrays. And the tricky thing here, the challenge that I want to address is that we don't want to serialize lists, maps, collections, and arrays. Yeah, it's strange to saying that, but the episode and the feature is to implement this serialization, and you are saying that it's not. We don't want to serialize them. Nope, we don't want to serialize. Imagine, for instance, an array. We don't want to serialize the array because array it's a class, it's a Java class. The same for a collection, for a map, or for a list. And we don't want to serialize this class here. This class, they have fields, they have attributes, and we don't want to go through all those fields and serialize their values. We are not interested in serializing the array. We are interested in the contents of the array. It's like the integer. We are not interested in serializing the integer implementation of the Java, but the value of the integer. And you say, but what is the difference? This is not what we will be doing since the episode 1. No, it's not. One thing is when we have a class like user, for instance, this user here, this is our class with these fields, and we want to serialize these fields. We want to take the name and the content of this name. But we want to do the same thing for an array. We are not interested in serializing this data type. We are interested in the items that are contained in this data type. We are interested in the strings that are contained, okay, inside this array. The same for the list. But we want to make sure that if we have a class that it's not a Java class but our class like user info, now it's different because we want to serialize this user info and its fields. But we are not interested in the fields of an array because an array it's a class. We are interested in the fields of user info because it's one of our classes. There is a small difference here, but makes a complete challenge to implement this because from the technical point of view, they are both classes. Okay, user info it's a class and string array it's another class. But for specific ones, we want to serialize them as is, but for the Java class or other types of class, sometimes we are only interested in their content. And that's the case for string, lists, collections, and maps. And that's why in this episode I've added this kind of output for each one of the fields that we are serializing. So it's a kind of a debug and making sure that it works. And I've added to our user two attributes, one permissions and departments representing an array and a list. I didn't add the map, which is one that I'm adding, and the hash set, which is a collection, by the way, but I can prove that it works, the serializer, because I'm serializing here the hash set and the map. I didn't want to create a complex output, more difficult to understand than the algorithm that was implemented. So I will run this. The main idea is just to serialize this object. We will see the output of these serializations, but then we will see a complete serialization of this user, which has all these different kind of data types, strings, booleans, and a custom class, let's say, a class that we really want to serialize, class that we don't want to serialize, we are only interested in their contents like these ones, and the same applies for the list. Okay, and then I have a pretty print with the help of this library that I will address in a future video. It's a very nice library that can be very useful in serialization and deserialization. I'm not using this class to serialize and deserialize. I'm just only using this class to make the output pretty, and you can see it, I think, somewhere here. If I'm not mistaken, you can see that the pretty print is just instantiate a JSON object, which, by the way, can validate our JSON. If we have problems in our JSON, it will fail. and then I do a toString with a factor of 4, which is the indentation. Okay, and this is this call. It's the only place where I'm using this. Okay, let's play this, run. Just a few seconds. And we can see here the output. More it's nice to see in this way. So we have our user, which is this one. Okay, this curly brace. Then we have our class, user info, that we want, which is this class here. It's one of the class that we really want to serialize, meaning that we are interested in the name of the field. But again, we are not interested in the name of the fields behind the array class. We don't care about those fields, we just care about the content. But in this class, we care about the field names and their value. Okay, here, salary, age. This is a string field. Now we have these permissions here. Okay, the permissions, it is this array here. Okay, and you can see that I'm interested only on the contents, meaning that it's because it's an array. The only thing that this name of the type array means to our serialization is that we want to use these brackets here. Okay, open and close, like the JSON brackets for square brackets that represent an array or a list. JSON doesn't differentiate between arrays and lists. Now we have a boolean here and departments. Again, now this is a list. It is this one, but from the JSON point of view, it's still a square bracket. It's an array and these values. Okay, this is the result of our serialization. How can we accomplish this? So the idea I had to refactor from my previous episode, the serializer, again, because of this thing that I've explained. We should consider the array, the list, the map, and even the enum and the collection as a kind of native types. Not native from the technical point of view of Java, but from the point of the serializer. The serializer doesn't distinguish between an array, collection, list, or map. At the end of the day, they are all the same array on the output as we saw here, which, by the way, I didn't show you. This is the map here. Okay, role, guest, permission, admin. You can see that it's serializing a map correctly with a key, okay, and the value. Okay, in this case we have a permission and a role. Okay, don't take seriously the contents. It's just they are real things, but we are not following a specific project with a specific enterprise application that can be somehow commercialized or used in a real implementation. The idea is just to understand the serializer. Okay, so again, let's return to our JSON serializer. So in this case, since we want to consider this kind of a native-ish, as I call them, data types from the JSON point of view, the serializer, the first thing that it does is just, okay, it receives the object and asks, okay, what kind of object do you want to serialize? It's a native one. And in this case, I ask if it's a native-ish. I refactor and created a method for this, and I serialize directly. This serialization, it's for these lines that we have here. It's always a good practice when we have when we are creating algorithms that somehow compose things like a tree, which is the case of a serialization, because you have an object that can have other objects inside, which, by the way, can have other objects. Usually we should start with the unit things, the leaves, let's say, of the tree. And in our case, the trees, or if you have a recursive algorithm, we should stop at some point, and usually it's a good practice to put on the start of the method. And we start when it's native. It's an enumerator because we don't want, again, to serialize the enumerator. We are only interested in the contents of the enumerator. The same for array, the same for a collection, the same for list, and the same for a map, and that's it. Okay, these are our native data types. For the native, we already saw in the previous episodes. It's just a switch asking for the simple name of the object and check if it's one of the real native data types of Java. If it's a boolean, a local date time, and date. These are examples of the things that I'm saying. It's local date. We don't want to serialize the local date. We just want to extract the value and format with a specific formatter that we are taking from the config. It's explained in the previous episode how it works, but that's the only thing that we are doing. And we can see here, we receive the object, we just format the date, okay, with this local date format, and this method format date, something that we have in format utils. Again, you can check my previous episode about this, and it's just a date time format, a regular one like the Java, and we extract the value and you format. That's it. We are not interested in the internals of the local date, and that's really important. For me, it's the main subject of this episode. It is exercise between understanding what is a class from the point of view of our project, which is a serializer, and what is a class from the point of view of the Java. They are different, okay, because the end of the day, JSON is just a string that we are sending. Of course, for the JavaScript, it's not a string, but for the serializer, it's just a string that we are composing. So there are some semantic things about the objects that we don't care, and we should be careful about what to discard or not when we are serializing. And in this case, we are not interested in the internals of the native data types, enumerators, arrays, again, collections, lists, maps, okay? We are not only interested in the contents. By the way, in Java reflection, we can ask if a class is enum, we can ask if it's an array, but we cannot ask if it's a collection, because a collection is an interface. It's not something that belongs to the types of class. But the array is a type of class, that's why it belongs to as a kind of a premium thing, which is array and is enum. But collection, list, and map, they are just interface that usually we use to implement our own lists, or even Java uses them to create array lists, hash sets, hash tables, and so on. And because of this difference, we don't have the is, but we have this one that we can use on the inverse part, meaning that we are asking if our object can be assignable to a collection. If that's the case, it means that it's a collection, and the same applies for the list, and the same for the Java. So our serializer with this feature can serialize any native-ish, again, data type. Okay, now what remains? The class, the real class, okay, that we are serializing. And for that, and what is the difference? It's like this one, but specifically we are interested in the fields of this class. So we are interested in the fields of the user. That's the difference, but we are not, again, interested in the fields of an array. Okay, that's the big difference. That's why this is the last step. If it's not native-ish, again, it is because it's one of our classes. Okay, so if it's one of our classes and we're interested in the fields, the first, probably the field is a private, so we should open the access to it. And then we just start to serialize the name of the field, like this, okay, or like this one. Imagine that it's user info, okay, now you have the colon here. And then, again, each one of these fields can be a native again, or can be classes. There is some kind of recursive thing, and there is a small duplication about the logic here, and it's very difficult to split this. It's possible to put this code smaller, but I think it's more understandable this way. So I wanted to make sure that the code is clear. So there was a trade-off here on the quality, because now we have we always know when to stop, and we have these returns when we are recursively serializing a class that can have or can contain other class and so on. And we have the bigger ones here when we process the fields, which by the way can contain classes, and call again this process. That's why there is this duplication, okay? But there is duplication only on the logic, not on all the lines. So the logic about serialization, it's not here. It's just calling serialize native-ish, and if you return here, you can see that I'm using the same line. So there is a few duplication for the sake of the clarity of the code. Okay, but again, we are now serializing our object. So imagine that is user info that appears, and it just will ask, it's a native one? No, it's not. It's an array? No, it's not. It's a collection? No, it's not. It's a list? No, it's not. It's a map? No, it's not. Okay, maybe it's a class that doesn't start with Java. if you saw one of my previous videos, you know it's a workaround to avoid Java classes in the serialization process. It's not accurate, but it's, yeah, but let's say it clears out the way for so many classes that can go wrong on the serialization. So if it's not a class that belongs to the package of Java, maybe it's one of our classes. On the next video, I will introduce annotations, and we can say clearly, okay, this is the class that we can use, or even you can use a configuration, say these are the classes that belong to this package. Maybe I will start with that on the next episode. Why not say, okay, I'm only interested in the serializer class that belongs to this package, and that way I avoid this condition here. I just check if the class belongs to that package, and if it belongs to that package, I'm interested in serializing it. Okay. But if it's one of these classes, I would just say, okay, so serialize it again, and it's recursive now. Now the user info, okay, it will be the parameter of this same method here. And again, it will check if the birth date, it's one of the native, it is, okay, it's a string, it will enter here. And if you enter here, you can see that we have something for the string, and it's serialize the string, which, by the way, serializing a string, it's quite simple. It's just to put double quotes, okay, and the string in the middle, okay, and then it just return, which means that it will print this here, and it will print the output. Okay, that's what will happen. So since it is recursive, it will work like that, and it will be applied if it's again, this is a user type, it's an enumerator, which means that it will be the field will, and the difference, okay, I forgot to talk about this. This prints the left part, okay, here, and the right part, it will be appended by this if, and then there is the continue, which is different from this one when we have a return, because this is the stop place, and this is just the continuation place, meaning that when we are inside this cycle, we are serializing a class. Okay, maybe it is a good idea to move this cycle to a method and call it something like we have here, saying, okay, now I'm serializing a complex object, and the code would be clear in that case. But let's return here. So this print the name, birth date, and this serialize the field, and we'll just print this string, and we add this symbol here, and the same applies for all of them. Okay, it goes through all the attributes here until it ends on the cycle here, and at the end we just remove this one when it's the last field. That's why we don't see it here. Okay, and we compose the object like this. It will build the JSON, and we compose like this. This content was the concatenation of this filter, this loop, and again, since this is recursive, okay, it should work for all data types. And that's it. That's what we did on this exercise, and that's why we have this output here. That seems correct. If it was not correct, this pretty print behind as a kind of a validation here. This JSON object belongs to that library arg.json. You can see it here, and this arg.json makes sure that your JSON is correctly formatted, and then it will do a pretty print and proves that our JSON is working. Okay, this is our serializer, and again, just in summary, the main idea is to understand that there are classes that they are our class that want to serialize, and there are other classes that belong to not only Java, but maybe external systems that we are not interested. We are only interested in their values and from specific fields or specific methods. For instance, in the array, you are not interested in the attributes of the array, you are only interested in the attributes of or the items that belong to or are managed, to be more precise, by the array. Okay, the same for the list, the same for the map and the hash set, because as you can imagine, any hash set, let's say if you go to the hash set, this is a class, and you can find for sure attributes here, fields that can be serialized or not, and we are not interested. Maybe this abstract set, there's some fields here, I try to find them. It's a lot to find. Okay, this is abstract. Boolean is empty. Boolean. Okay, for sure there are fields here, or at least gets that are useful, but you cannot implement a list or a collection without using fields. At least you should have a place where you allocate memory and put the items there. But they should for sure have fields. And we are not interested in serializing this class here. We are only interested in these values here. And that is the lesson for this episode. And that was the challenge that required me to change and refactor the code. I think this code is more readable now and it's clear to be better understood. So thanks for watching the video. If you're interested in the code, please leave a comment. Usually I don't put there the code, but I have for all the episodes and all the versions. I always create a zip in my machine with the content. So if you think it's useful for you, I can just put the link there, or maybe put in GitHub, and you can download it from there. I hope you liked the episode. I hope to see you on my next video.